Today we will study the electric field intensity of an electric dipole in a simple and clear way. But before we go further, let's explore few curiosities that frequently pop up in our mind, like what happens when two opposite charges come together? What does intensity actually means? Electric field due to a dipole, field on axial position. So after watching this video, you will be able to answer all of these questions, but you will have to wait a little more. So please stay with me. So hello everyone, Namaskar and greetings to all of you, and welcome to my channel Wave Action. We are going to dive into a very important topic, intensity. So let's get started. Before explaining the intensities, it is essential to understand some important things such as lightening the bulb and hammering the nail. With the help of these two examples, we understand what is intensity. So first of all, we take first example, lightening the bulb. When you switch on the bulb, your eyes feel some brightness, and as you move further to the bulb, your eyes feel more brightness. We see what it shows. It shows that as you move closer to the bulb, your eyes perceive more brightness, and this brightness is in the form of intensity. Similarly, when you hit a nail with your hammer, the nail feels some efforts in the form of pressure, and again, with a harder blow of hammer, the nail feels more pressure again, and this pressure is in the form of intensity, or you may say that this pressure is a intensity in a mechanical way. More example can also be given, but due to boot time limitation, we cannot provide more example. So let's move on. So here a definition of electric field intensity of a dipole at the axial position. So the definition is the electric field intensity of a electric dipole is the net electric field produced at that point by both the charges of the dipole, and it is equal to the vector sum of the electric field due to each charges. That is, vector ED is equal to vector E minus Q plus vector E plus Q. Here D represents dipole. So this is a formula, and this formula is called definitional formula because it is based on the definition. But in this definition is given that the main point is the electric intensity of the electric dipole is the net electric field. Net electric field produced at that point by both the charges at the dipole and is equal to the vector sum. Vector sum here is vector sum of the electric field due to each charges. Due to each charges. So here we have underlined the essential points. So on the basis of this definition, we draw a figure. So first of all, we draw a dipole like this, and we take a 2 points on this line, and the name of these lines as given A, B and O. Here we place minus Q charge, and here we place plus Q charge, and along this line, either this side or this side, we take another test charge, that is Q naught, and the distance of this Q naught from the center is small r, and we written here distance of the test charge from the center. So the distance of test charge from the center is small r. So here the definition is given that the net electric field produced at this point will be the vector sum of the electric field produced by minus q and plus q. So we see here that q naught is more closer to plus q with respect to minus q. So this charge produce more electric field intensity, that is called E2, and this minus charge is more far away with respect to this, so this charge will produce at the same point in the opposite direction of E2 is E1, and electric field intensity produced by these two charges will also in the form of vector. So according to definition, this is this. And now finally we have to define the distance of test charge q naught separately from minus q and plus q. So the distance of q naught from plus q is r minus l, because the distance of OA and OB is L, because it is a dipole, and the L represents a very small distance between these two charges. So the distance from O to Q is R, but the distance from plus Q to Q naught is R minus L, and the distance will be minus Q to Q naught will be R plus L. So now we have to calculate the intensity produced by this dipole at this point with the help of E1 and E2. Here we see that E1 and E2 is in the form of vector, but we will take here in the scalar form. So what will we do? We do modulus of vector E1 is equal to E1, and modulus of vector E2 is equal to E2. So we see that because E2 is greater than E1. So now place the formula of E1 and E2 separately like this. So E1 is equal to 1 upon 4 pi epsilon naught capital K and Q upon. So distance for E1 will be R minus L. So R minus L whole square of R minus L, and this can be given number 1, and similarly E2 is equal to 1 upon 4 pi epsilon naught capital K Q upon R plus L, the whole square of R plus L, and this is number 2. What we know that here E2 is greater than, so net electric field produced by the dipole at point, now you can place here point P. At point P is E is equal to E2 minus E1. Now place this formula in this line. So what we see, 1 upon 4 pi epsilon naught capital K Q upon R minus L whole square of R minus L minus 1 upon 4 pi epsilon naught capital K Q upon R plus L whole square of R plus L. Now taking some common, as you see here, 1 upon 4 pi epsilon naught K and Q in both the terms. So taking out some common like this. So in bracket we get 1 upon whole square of R minus L minus 1 upon whole square of R plus L. This. Now solving these two terms in the bracket. So first of all we take LCM like this, whole square of R minus L and whole square of r plus L, and here we place whole square of r plus L minus whole square of r minus L. You see here both the terms has square. So these two terms can be placed in only one brackets. Again 1 upon 4 pi epsilon naught capital K Q, and here we place big bracket or box bracket. So now open these two brackets, r square plus L square plus 2 RL and minus R square minus L square plus 2 RL, and here we get R plus L, R minus L, R plus L, here. So R square plus minus R square, these are equal and cancelled out. Similarly for L square. Now these two will be add because these two have same sign. So we proceed here. E is equal to 1 upon 4 pi epsilon naught capital K Q, and here 4 RL upon, this will make a formula. What is that? That is R square minus L square in bracket, but here will become square. So as you know that, as we know that L is very less than R. So L square is very less than with respect to R square. So L square can be leaved, can be leaved, and hence E is equal to 1 upon 4 pi epsilon naught capital K Q 4 RL upon R is the power 4. Now again solving this terms, we get 4 pi epsilon naught capital K Q 4 L R Q. Now taking this Q inside this box, so we get 1 upon 4 pi epsilon naught capital K 4 QL upon RQ. But we proceed here due to the lack of some space. So you know that uh, we write here, but P is equal to 2QL. So here is 4 and 4 is a product of 2 into 2. So we can write E is equal to as 1 upon 4 pi epsilon naught K and 2 into 2 QL upon RQ. Again E is equal to 1 upon 4 pi epsilon naught capital K 2 P RQ. Here is our formula of intensity, net intensity at this point by these two charges. So hence we call it the intensity produced by this dipole at this point is this. So please note down this whole derivation. And now we will further discuss the information of the intensity of a dipole and application of the intensity of dipole. So please note down. Now guys, as you see here, this formula is E is equal to 1 upon 4 pi epsilon naught capital K Q upon R cubes. So it means the electric dipole is placed in a dielectric medium. If the dielectric is placed in a vacuum, so K will become 1. So this formula will become this. Means E is equal to 1 upon 4 pi epsilon naught Q upon R cube. So on the basis of this formula, we have some information and application. So the first we will talk about information. So what are the information given by this formula? The first information is field decreases as 1 upon R cube and it varies as 1 by R cube. Means as you go out from the dipoles, so the electric field intensity will go decrease very fast as compared to distance. And the second is direction is along the electric field movement like this. So this is a electric field movement of a dipole, and the electric field intensity is the same direction as electric field movement. Now other is application of the intensity. So the application of intensity are polar molecules, capacitors, dielectric materials, and molecular bonding. So as we have discussed in the start, 4 questions have been asked. So first question is, what happens when two opposite charges come together? So when two charges come together, they make a dipoles. But in the case, it should be opposite nature and equal in magnitudes. The second question is, what does intensity actual means? So actually, the intensity means is force per unit charge. And third question is electric field due to dipole, and the four is field on the axial position. These two answer will be given by a figure as we have seen in this video. So here you will see clear that all the problem has been resolved. So that's all for today's videos guys. If this helped, please like, subscribe, share, and also comments for your doubts and queries. Take care and creating, and thanks for watching this video. Goodbye.